Welcome to the video series, The Operational Amplifier, From Abstraction to Reality. Perhaps the most popular and widely used op-amp was the 741. The modern-day product offerings for operational amplifiers are significantly improved. The 741 op-amp had a major impact on the market when it was released in 1968. It quickly became the most popular and widely used op-amp on the market. It was more consistent from chip to chip. It provided smoother amplification. Perhaps most of all, it was cheap compared to the previous op-amps. I'm told the 741 is still being used for training in some classrooms. Its performance is in stark contrast to that of today's op-amp performance. Me, being very visual, I thought it would be more revealing to juxtapose the 741 specifications with that of modern-day op-amps. The column on the upcoming graphs, labeled Modern, does not represent the best with regard to a specific spec, but are rather ones I found to be generally provided across op-amp products. I think the biggest limiting spec on the 741 is the minimum power supply voltage. The spec is plus or minus 10 volts or 20 volts total. Modern rail-to-rail op-amps can operate on supply voltages as low as 1.8 volts. While the input offset voltage of the 741 was quite good at the time, even non-chopper op-amps have input offset voltages as low as 10 microvolts, 1% of the 741 at 1 millivolt. The input bias current of a typical modern op-amp is in the picoamp range. The 741 is 16,000 times higher. The input offset current of a typical modern op-amp is in the femtoamp range. The 741 is 40,000 times higher. The common mode range of the 741 was only 80% of the rails, whereas now there are rail-to-rail and beyond op-amps. The maximum peak output voltage swing of the 741 was only 80% of the rails, whereas there are rail-to-rail op-amps that are 99%. Modern op-amps have improved their large signal differential amplification by about 60% over the 741. The input resistance of a typical modern op-amp is in the teraohm range. The modern versions are 7.5 million times higher than that of the 741. There are significant reductions in open-loop output resistance. Input capacitance has not seen much improvement, as most of that is associated with the parasitics of the interconnect to the device. Common mode rejection ratio sees about a 3.2x increase in modern parts. Power supply rejection ratio sees about a 3x increase in device offerings. That's at DC. Perhaps it's even better at high frequencies. I was not able to find any rejection charts of the 741 at higher frequencies. Power supply current has also been greatly improved with CMOS and JFET op-amps, about 1/100th of the 741. Gain bandwidth is a major game changer, at a moderate 520 times higher. Some are in the gigahertz range. And finally, the 741 noise is about 70 times greater than the current devices. So bottom line, there's no good reason to use the 741 with such great modern-day op-amp product offerings available. Thanks for watching. Please click the like, subscribe, and notification bell so you don't miss any upcoming content.